Hey guys, today we're going to do 9-2 and 9-3 arithmetic and geometric sequences. You will be able to define, identify, and apply both arithmetic and geometric sequences. So first, an arithmetic sequence is a sequence where the difference between consecutive terms is constant. This difference is called the common difference. An arithmetic sequence with a starting value a and a common difference d is the sequence of the form a plus d, a plus 2d, a plus 3d, and so on. We have a recursive definition for this sequence that has two parts. A sub 1, or our first term or our initial condition, is a, and our recursive formula is a sub n is equal to a sub n minus 1 plus d, where n is greater than 1, or our term number is greater than 1. An explicit definition for the sequence is a single formula. A sub n is equal to a plus n minus 1 times d. So first, identifying arithmetic sequences, we need to see if we have a common difference. So how do we get from 6 to 3 plus 3 plus 3 plus 3 plus 3? Since the difference for each between each consecutive terms is the same, yes, this is an arithmetic sequence.
Adjacent arcs are arcs.
Now we have 1, 4, 9, 16, 25. To find our common difference, we take the second term minus the first term. 4 minus 1, which is 3. Then the third term minus the second term. 9 minus 4. 16. Since we have two differences, this is not arithmetic.
So what's the measure of each arc in circle C? So PR.
So what is the 100th term of an arithmetic sequence that begins 6, 11, and so on? So we know that our first term is 6. The common difference is 11 minus 6, which is 5. And we are going to use our explicit formula, which is a sub n is equal to a plus n minus 1 times d. So we're going to substitute 100 for n because that's the term number, 6 for a because that's our initial condition, and 5 for d because that's our common difference.
And P, Q, R is going to be everything except that 77.
So we'll get 99 times 5
we get
plus 6.
77. We get 283.
Our 100th term is equal to 500.
So the circumference of a circle is the
What are the second and third terms of this arithmetic sequence? 100, then we don't know the second and third, we know our first, and we know our fourth term. So what I'm going to do is think about, this is our one common difference, two common differences, three common differences. So to go from 100 to 82, we did that over three differences. That is equal to 18 over 3, which is 6. But since we're going down each term, it's minus 6. So 100 minus 6 is 94. 94 minus 6 is 88. 88 minus 6 is then 82. We can also find the arithmetic mean or average of two numbers, which is x and y, of x and y, which is x plus y divided by 2. The middle term would be considered the arithmetic mean. So what is the missing term of the arithmetic sequence? 15, we don't know, and then 59. So we're going to take 15 plus 59 divided by 2. 7 74 divided by 2, and we get that middle term would be 37. Now on to geometric sequence. A geometric sequence with a starting value a and a common ratio r is a sequence of the form a times r squared, or that's the same thing as a times r, and then a times r to the third. So now this is a ratio. This is a ratio now because we are multiplying or dividing by a common number to get to the next term. Our recursive definition is a sub 1 is equal to a, and our recursive formula is a sub n is equal to a to the n minus 1 times r. Our explicit definition would be a sub n is equal to a sub 1 times r to the n minus 1. So we need to check if we have geometric sequences. So we're going to take 6 divided by 3, which is 2. 12 divided by 6, which is 2. 24 divided by 12, which is 2. 48 divided by 24, which is 2. Since we have a common ratio, r is equal to 2. Our first term is equal to 3. Now we have 3, 6, 9, 12, 15. 6 divided by 3 is 2. 9 divided by 6 is 3 over 2. These are not the same, so these are not geometric. Here we have 3 to the 10th over 3 to the 5th. We could subtract exponents and be left with 3 to the 5th, 3 to the 5th, and 3 to the 5th. So this is geometric. Our ratio is equal to 3 to the 5th power. If we want to find the 10th term of a geometric sequence 4, 12, 36, we know our first term is a to the first. Our first term is 4, and our common ratio is 12 divided by 4, which is 3. The explicit formula was a sub n is equal to a sub n minus a1, or our first term, times r to the n minus 1. Substitute 10 in for n, 4 for a1, a sub 1, and 3 for r. So 4 times 3 to the 9th power. Simplify. 3 times, oh man. We are not going to do that. Geometric mean is now not going to be, we're finding the average, but we need to take the square root of x times y. So if we have 3 blank 12, we would do the square root of 3 times 12, which is the square root of 36, which is 6. That's all for today.